Project Smart Retail is an AI-driven system for customer channel analysis, dynamic LTV, and intelligent retail decision making. The introduction is due to the rapid digital transformation of the retail sectors. So, has generated massive volumes of transaction, customer, and operational data, creating both opportunities and challenges for decision making. So, accurate sales prediction and demand planning are critical for maintaining an optimal inventory values. So, artificial intelligence has emerged a powerful solution to overcome these limitations by integrating the customer churn analysis and dynamic customer LTV, which will allow to understand the customer behavior and predict their sales value and their behavioral pattern. So retail business face significant challenges in predicting store level sales and planning demand accurately due to dynamic market conditions, fluctuating customer preferences, and complex data platforms. So existing forecastings are very static and will not be able to understand the dynamic customer change in behavior. So therefore, they need an intelligent adaptive system that can be accurately predict the sales forecast, demand, and dynamic evaluate the customer value to support data-driven decision making. So the retail industries generate large volumes of sales and customer data, making accurate demand forecasting essential. Then the traditional methods are static models and often fail to capture the customer behavior. So a key feature is dynamic customer lifetime value, which continuously evaluates customer value, and the proposed framework helps retailers optimize the planning and reduce stock stocks. So these are the literature reviews. So the issues and challenges: inaccurate sales forecasting due to reliance on static historical data, overstocking and understocking, cost poor visibility, and inability to adapt to seasonal trends, and limited understanding of changing in customer behavior. Fragmented and improper data, high cost of operational value, lack of real-time insights, and traditional TV does not support customer changing in behavior. So we are collecting the data. This is the proposed framework. Collecting the data on retail and churn data sets, reprocessing it with the ETL, and the EDA is performed, then implementing the machine learning algorithms, then predicting the churn customer and the dynamic customer value. The decision engine tells whether the customer has to churn or they can be having a good lifetime value. Then the deployment integration part is there. Then the visualization and the dashboards. The system requirements, these are the software requirements and these are the hardware requirements. So software requirements are with Anaconda, Jupyter, and Xcode, and hardware requirements need an Intel Core i5 processor with minimum 80 GB hard disk and 4 GB. So the proposed framework tells you about how we are implementing this dynamic LTP. Then these modules, starting with the data collection modules, all the data are collected in the form of CSV file. The high quality data collection ensures the completeness, accuracy, and reliability, which directly impacts the downstream machine learning and performance. Then the data processing and feature engineering, where the ETL is performed, cleaning, transformation, enriching the data so that missing values are not there, and inconsistencies and normalizing the numerical attributes, everything is tempered. Then EDA, that is the explorative data analysis, which provides the critical insights into customer behavior, sales trends, and data distribution before modeling using statistical summaries and visual techniques. This model helps to understand the future relationship and detecting bias and validating business assumptions, thereby guiding model selection and optimization. Customer churn prediction identifies whether customers are likely to stop purchasing from the platform. Machine learning classifiers analyze the historical pattern and their transaction frequencies and their inactive periods to understand them and improve the customer satisfaction, reducing the revenue costs. And the dynamic customer LTV, they'll be estimated based on the long-term value of the customer by dynamically modeling purchasing behavior over time. Unlike static LTV, dynamic LTV adapts to changing customer behavior and preferences and engagement levels. Then the prediction decision engine, it is an recommendation of optimal promotional strategies using intelligent decision making logic by combining predictive models, customer segmentation, and reinforcement learning principles. This model determines the best offer, discounts, and timing for the individual customers. So deployment integration, this model additionally gets into machine learning model by integrating world. They are deployed using the API or cloud-based services to ensure scalability, reliability, and minimal latency. Then visualization and dashboard. So we'll be visualizing the metrics such as churn risk, CLV segments, sales forecast, promotion performance, etc. So these are the implementation parts. So this is the prediction of the inventory forecast. With the date, we'll be able to know whether it's understocked or overstock. And this is the customer churn behavior, whether we'll be able to say the customer will churn or stay, and what can be done, etc. These are the references. Thank you.